In this lecture, we will introduce classes, objects, and structures.
Remember that Visual Basic is an object-oriented programming language. What this means is every single object we have in Visual Basic is defined by some class. Now, classes and objects in Visual Basic work the same way as other languages like Java. So each class would describe all the variables, the properties, procedures, events, methods, operations, anything that we do for a particular object. So like, for example, if I have a text box, that is an object of the text box class. The text box class has all these different variables and properties and everything we can do for a given text box. The objects themselves would be instances of classes. What we're saying here is for any given class, we can create as many objects as we need, assuming we have defined the class, of course. We have to define it first, but once we've done that, then we can create as many objects as we want of that class and use it in our forms. Here's one analogy we can use to help with this relationship between classes and objects. So think of a class as a cookie cutter, and an object would be a cookie. Everyone likes cookies, right? So the cookie cutter would be our class because it defines the characteristics of the cookie. So it defines things like the shape, the size. So maybe you're doing like circle cookies, or maybe you're doing little shapes, maybe like gingerbread men cookies, I don't know. But cookie cutters would define all the characteristics of our cookie, of how it would look, how big it would be, how small, and so forth. The class itself would then be used to create the objects. So the cookie cutter would be used to make the cookies. So that means our objects would be the cookies. So you have much cookie dough, and you would use the cookie cutter to make as many cookies as you want, and each of those cookies would have the same characteristics that were defined by the cookie cutter. The same thing is true with this relationship with classes and objects. The class defines the characteristics of each object. You can create as many objects as you want, and every object has the same characteristics that were defined in our class. Visual Basic does have another feature that you may not have seen before unless you're familiar with C or C++ programming. This is what we call a structure. Basically, a structure is a combination of data items of different types. So for example, we could have a structure with several integers, or several floats, or characters, or a combination of all of them. And in fact, what we do is whenever we declare this type of structure, we're essentially creating our own data type. It's called a composite data type. So what we're doing here is we're just pretty much taking a bunch of different variables, and we can even include sub-procedures as well, but we can combine them together in a group, and that is basically this new data type that's defined by having these different variables and subs together. And we can even declare variables of that type. It's actually very similar to classes and objects. The only difference is we don't have to instantiate the object that we can create. So we can define a structure that has our variables and our subs, and then we can create however many variables we want of that structure. So how do we declare a structure? Well, it's pretty simple actually. The first step is we need to create beginning and ending statements for our structure. So the way we do that is we would start with the line private structure name, and then we would end it with end structure. Similar to what we've seen with other structures like if-then statements and loops, where we would have some words to indicate the beginning and then some words to indicate the end. So we would start with private structure name, where name is whatever we call this structure, and then we would end with end structure. So then the next step is to add the elements to the body of the structure. So between these two statements, we would add all the elements that we want as part of this structure. Now there are a couple things we need to mention about the elements that we include in here. There has to be at least one element. You can't just have like a structure with nothing in there. So you have to have at least one element part of it, and each element has to be declared. So you're just basically including declaration statements, and you have to specify an access level for it. So we're saying, is each element public or private? You have to specify one or the other. And also we can mention that elements can be variables or sub-procedures. I think we mentioned earlier that we can have variables and subs, so each element has to be either a variable or a sub. Here is an example of a structure in Visual Basic. So we see at the very top up here, we have private structure employee. That tells us that employee is going to be the name of our structure. So think of this as the name of our new data type. And then down here we have end structure, so we know this is the end of declaring our structure. And then everything in between would be the elements of the structure. So that means we would have variable declarations, we would have subs defined in here as well. So we see we have a variable called first name, which is a string. We have a variable called last name, which is a string. We have a salary, which is a variable type double. And then we have a sub defined called give raise, where we pass some raise, which is a double. I'm guessing it's going to be some percentage, where the sub is defined as taking the salary, multiplying by the raise, and then storing that back into our salary. So all of these elements would be composed of the employee data type, technically. Like I said, we're basically creating a new data type called employee, which is going to consist of two strings, a double, and a sub. Now, once we have defined our structure, we can now declare variables of that type. Like I said before, when we create a structure, think of it as creating your own data type. So how do we do that? Well, let's use an example to help illustrate this. So let's say we go back to our employee example for our structure. So we would say something like this. Dim, and we'll call it my employee, and then we have the word as, and then we just put in the name of our structure as our data type. So in this case, we call it employee. It's just like any other declaration statement. The only difference is instead of using a pre-made data type like integer or double or string, we just use the name of our structure. So once we have that, now we can work with the elements of the created structure. So how do we do that? Well, the way we would access an element is we would have the name of the structure, so the variable that we have declared, a dot, and the name of the member. So this is just like in object-oriented programming where we would have an object and we have the name of it, a dot, and then the name of the attribute or the method. The same thing goes here. So for example, maybe I want to modify the first name of an employee. So I'd have my employee dot and then first name, and I can set it equal to a string like Joe. So this means the first name of my employee is going to be Joe. Visual Basic actually does have a couple of pre-made structures that we can use. So let me just give you a couple of these examples. So both point and size are examples of structures. Now, if you don't remember what point and size are, let me give you a reminder. So let's suppose we have some tool like a button. The point structure, the point object, gives us the location of the tool. So remember in the property where we can get the coordinates, we have an x coordinate and a y coordinate. I believe they're actually set up as x position and y position, but the point is actually a structure that tells us where is this button located in terms of the x and y coordinates. And the size object would give us, well, the size of the tool, the width and the height. So the size itself is a structure where we have two values, the width and height. So both of these would be examples of structures.